Welcome to week 6 of Linear Equations with Mrs. Whybark. This week we will be learning about linear equations presented in standard form. We will be converting them from standard to slope-intercept form and graphing linear equations presented in the standard form. We are first going to take a look at the definition of a standard form linear equation. When an equation is written in standard form, it is presented as ax plus by equals c, in which a is always greater than 0. That's just another way to say that a is positive. Also, a and b are not both 0, and a, b, and c are all integers. An example of such an equation would be 2x plus 3y equals 12. Our goal this week is to be able to graph linear equations presented in standard form. There are two different methods for doing this. The first method is to start with the standard form and convert it to slope-intercept form, which is y equals mx plus b. There are 3 steps to do this. In the first step, you subtract ax from both sides or add it, if needed, in order to get the by term by itself. This would yield by equals negative ax plus c. We then divide everything by b to get y by itself, giving us y equals negative a divided by b times x plus c divided by b. You then graph the y-intercept, which would be c over b, and use the slope negative a over b to find a second point. Please go to the second page of your notes where we are going to take a look at how to do this. In this first example, we have the equation 3x plus 5y equals 15. Our first step is going to be to rearrange this equation into slope-intercept. In order to get y by itself, I am going to first subtract 3x from each side. In doing so, I will get 5y equals negative 3x plus 15. My next step in isolating y is to divide each term by 5. Remember, you have to divide every single term in the equation, not just once on each side. On the right, you have to divide both the x term and the constant. This will give me the equation y equals negative 3/5 x plus 3. I now have the slope-intercept form of this equation, and I can graph it as we've been doing all year. So my y-intercept is now 3, and my slope is negative 3 over 5. So in order to graph this line, I'm going to start at y is 3, which is here. And then I'm going to use my slope of negative 3/5. That means I start at my y-intercept and I go down 1, 2, 3, and to the right 1, 2, 3, 4, 5. So I now have 2 points which I can connect in order to make a line. And this is the first method for graphing an equation presented in standard form. Going back to the first page of your notes, we're now going to take a look at the second method for graphing. When given an equation in standard form, often the easiest way to graph it is to find the x and y intercepts. In the first step, you can find the x-intercept by plugging in 0 for y and solving for x. This would give me the x-intercept. In the second step, you find the y-intercept by plugging in for 0 for x and solving for y to get the y-intercept. And lastly, you graph the x-intercept and the y-intercept, and then you draw a line. We are now going to take a look at how to graph the same equation using method 2. My first step is to find the x-intercept. To find the x-intercept, what I'm actually going to do is plug in 0 for y. Remember that if I am on the x-axis, the value of y will always be 0. So I'm going to use my original equation, 3x plus 5, and in this case, I'm going to let y be 0 equals 15. 5 times 0, of course, is 0, so I get 3x equals 15. To solve for x, I will divide both sides by 3, which gives me the answer x equals 5. This means that I have the point in which x is 5, and remember, y is 0, because I let y be 0. So I can now graph the point 5, 0. So starting at the origin, 1, 2, 3, 4, 5. And this is my point right here, 5, 0. Next, I need to find the y-intercept. I'm going to use a similar process, except now that I'm looking for the y-intercept, I'm going to plug the 0 in for x. Because you'll recall, if you are on the y-axis, then x is always equal to 0. So this time my equation is 3 times 0 for x plus 5y equals 15. 0 times 3 is, of course, 0. So I am left with 5y equals 15. I'll divide both sides by 5 in order to solve for y, and I get the result that y equals 3. So this gives me the point where x is 0, because I let x be 0, and y is 3. And this is my y-intercept. So I can also graph this line right here, or this point rather, graph this point, 0, 3. Now that I have 2 points, I can draw a line. So as you will see, we have used 2 different methods to graph the same line, and of course we got the same exact results. This is what your first page of completed notes should look like. Thank you for watching this Whybark production.